Hey everyone, we're back for another week on this virtual learning environment. I hope everything's going well for everyone. I just want to tell you to hang in there and just keep working at things and doing your best. I appreciate the work that you're putting in on the course, and this is a difficult time, and we'll have a forum for questions after we're doing an energy chapter today for this week, and there'll be a forum for questions. But feel free to drop me an email or reach out to me if you want to tell me some things or share what's going on in your lives. It's hard to not see you guys face to face. Miss our classes together. So please, if you have prayer concerns or other things like that, just feel free to reach out to me, send me an email, and connect with me that way. So I'm going to go ahead and share my screen here so that you can see the PowerPoint, and we'll jump into today's lecture on energy. So in this lecture, we're going to, cover what is energy, why, what do we use energy, how do we produce it, and what are the impacts of these production methods that we do have. So energy is not really a thing. It's described by what it does. So energy is the ability to do work, to move objects, cause change, things like that. So energy is harness for things like transportation, heat, electricity, cooking, and most other uses probably could be classified based on other things like this above. So energy cannot be created or destroyed, if you remember those laws, right? But it can change forms. And so energy is used for daily things that comes from processing and harnessing energy from nature. So the question is, what are those sources and how do we get them, right? So we have solar energy, we have nuclear energy or atomic energy. Those are the two main sources, right? So sources of energy alone are perfect. None, I should say, none are perfect, none are terrible, but they have pros and cons, right? And so we're going to go through that. So we have fossil fuels, so coal, natural gas, oil, nuclear energy, and then renewable energy, things like hydro and wind and solar. Okay, so when we look at the energy sources for the United States, so this is in 2016, it varies by region and varies worldwide, but in the worldwide, we see that non-renewable sources, so things like pretty much natural gas or fossil fuels, is 83.3%. Renewable sources is 12.7%. And that's starting to come up. It's renewable energy is on the uptick, especially because now renewable energy is a lot cheaper to produce than fossil fuels. So most of the electricity that comes to our outlets, especially in the United States and especially in the Midwest and in East Coast and West Coast, maybe not so much in the Pacific Northwest or maybe not so much in the South. We have the Southwest, but most of our electricity is coming from coal. Okay, the energy production is our way of capturing, converting, and storing energy that's available in nature. So how do we take the energy that's already in something else and convert it into something that we can actually use? So a lot of, this is, producing heat that moves a turbine that allows for energy to be produced. So the goal then, in general, if we think about sustainable energy use, the goal would be to provide abundant energy that produces little pollution, is abundantly available, and is renewable. So those are our, goals when we think about energy production, right? So, it's interesting to think about what the future will be like with energy, and things are even in the last, 10 to 15 years have changed quite a bit. So again, most of our energy still is coming from fossil fuels though. So fossil fuels are coal, natural gas, and oil. So we're gonna start with coal. So coal was produced from old ancient vegetation that got buried and compressed under heat and pressure that allowed for coal to be produced. And so it gets kind of buried under sedimentary rock, and so there's these kind of coal veins. And other fossil fuels, and the reason why they're called fossil fuels is because they're ancient living things. So oil and natural gas are from microscopic marine organisms that are compressed under heat. And again, so this either going to be found in the under the ocean or found in places that used to be ocean. Okay, so when we look at recoverable coal reserves, one of the reasons why a lot of our electricity is coming from coal is because that, you know, when you look at the coal, we have one of the bigger amounts, and also the Soviet Union. This makes sense because we have similar kind of climate to those groups, right, compared to some of these others. Whereas, you know, you have more oil reserves in these areas, right? So there's one thing that you hear a lot is this idea of resources and reserves. So resources is a geologic term. So that's saying how much total is available or it exists, right? So how much, you know, if we're talking about it from a geologic standpoint, how much coal is out there? How much oil is out there? How much natural gas is out there, right? What's the big thing? The reserve is more of an economic term. And so how much can we extract and still make a profit? So not all of the resource is bigger than the reserve, right? Because the resource is, well, it's there. Well, some of it just you can't get to, right? It's just too expensive and things. And so the reserves are what are profitable for reserving, for collecting. So you can see that that's a smaller amount, right, than the resource. The resource doesn't grow, it stays the same. The reserve can change and grow if, you know, you get better technology, better ways of getting at stuff, or if things become, in a lot of the cases today, it's that fossil fuels are becoming more rare, and so some of these kind of undesirable sources are becoming more desirable because they just aren't there. So how coal generates electricity is you burn the coal, and that boils water, which creates steam, which turns a turbine, which causes a generator to move. And so that allows for energy to be produced. Coal has some issues. Coal is one of the most abundant fossil fuels, which makes sense. Vegetation, most things, vegetation. Mostly used to generate electricity, pretty cheap because of that. But it's pretty dirty. It's the most polluting of the three fossil fuels. And right now we have enough to last 150, 200 years, right? So it's dwindling. One of the things is how we get the coal. So we have surface mining, where it's the mountaintop removal. We're taking off layers and layers that can't be recoverable. That kind of ruins the land. Or we go under the ground and do underground mining, which is pretty unhealthy, and safety is a problem. And then because we're opening up these deposits to surface weathering, like water and wind and things, there can be drainage, there can be acid runoff. And then there can be a lot of air pollution. So as we're burning the coal, well, you can have coal dust that is just blowing off of the coal, which can be bad for people's lungs. You can have sulfur, mercury, acid rain, and CO2 are all things that come from burning of fossil fuels, burning coal, and we get a lot of mercury disposition into fish. And so fish have become unsafe to eat, especially for pregnant women. And so when you look at places where there is a high level of people eating fish culturally, you start to see a lot of mercury found in those people. And mercury can affects development, so it can affect how the brain develops, which can be a problem. Oil and natural gas are considered superior to coal because it's kind of a little more bang for the buck. They're less environmental damage in extraction, but they can cause damage in spills and things. It's cleaner, in quotation marks, less pollution, so not the mercury and other things like that, but and less CO2, but still quite a bit of CO2, and it's easier to transport. But there's fewer reserves available, so there's a lot more infighting about that. Part of why we have reduced gas prices right now is not necessarily just for COVID, but it's because there's kind of this conglomerate of big oil producers called OPEC. And right now, Saudi Arabia, one of the big OPEC guys, and Russia, one of the big OPEC guys, are kind of feuding. And so they're having kind of a price war. And so that's also bringing the cost down. In addition to our supply has gone up because we just aren't needing it as much when we're not driving around. Most of our new discoveries are new, when we talk about, resources versus reserves, the new reserves are coming offshore. They're under the ocean. These used to be kind of off limits, used to be thought of as just not useful and extractable, but through technology, we've been able to do that. Very dangerous though, if you look at the BP oil spill, right? Where the whole oil derrick kind of blew up and just opened up. I mean, took them days and days to cap off this oil. U.S. used to have pretty good oil production. So back in the 60s and 70s, but then it peaked in the 1970s. So the peak came as a surprise, and so there was all kinds of kind of a big recession and worry about kind of this oil worry. And so we started to find oil other places, not only trying to find it domestically, but also, that's when we started making relationships with other oil countries. So we peaked in the 1970s, but then we have kind of gone down when we have kind of a new second wind of energy, and this is coming from fracking. Okay, so we're kind of getting a new wave of oil production because we've looked at, we're going to kind of ickier sources. So this is kind of how I think of it. So when you have a person who's an alcoholic, right, they start with they might start with beer and liquor and things like that, but eventually they become so desperate because they're so addicted to that substance that they'll start, as people start to kind of intervene and try to keep them from drinking alcohol, they might start drinking mouthwash, and they might start drinking rubbing alcohol and things like that. And so it's this idea of going to these ickier, more dangerous, more damaging sources of oil because we're so addicted to oil. So fracking is one of those. It's pretty controversial. So what happens is you put a pipe down here, you shove sand and water mixture in here, you're kind of basically filling up these gases, filling up these gaps. And so the fracking oil in these shale deposits they're very dispersed. And so it's not as easy to kind of tap in and suck out all the oil. So it's dispersed. So you pump in all this, you add pressure, you break the rock and fracture the rock. And so you're fracturing the rock with this sand and water. And so hopefully what's happening is then that oil is kind of moving into these fractures and collecting, and then you're pulling that out. And so there's a lot of chemicals, a lot of icky chemicals that are involved, a lot of water usage, A lot of those icky chemicals have become water pollution problems for people who live near fracking sources. And there's been an increase of earthquakes in places like Oklahoma and Montana and the Dakotas, places that you wouldn't normally have earthquakes. Okay, and so it's not great. Okay, so it is rising, right? Because because of the fracking and because we have more efficient cars and more alternative transportation, so we don't need as much oil as we used to. And so the U.S. dependence on foreign oil decreased, but it's rising again. And again, part of that is because some of these oil booms are kind of boom and bust kind of thing. So this fracking was great for a little while, and now it's kind of running out. So when we look at our current use of oil, we have a supply of about 60 to 100 years. And the Middle East has 61% of those reserves. And then the US has the second largest reserves. So when we think about, the Middle East, we think about how unstable they are, right? And how it's not necessarily great for us to be kind of dependent on the Middle East. So if we want to be less dependent on foreign oil, we either have to find more oil here. So there's a lot of exploration that's happening. We either have to conserve and use less oil, which is happening right now because of our pandemic, or we have to find alternative fuels, right? And alternative ways of doing things like transportation. Natural gas is another fossil fuel, so we use this in heating, cooking, hot water, transportation in some cases. The extraction is similar to oil, but it's the cleanest of the three fossil fuels. There's some extraction issues because a lot of this oil boom is also causing us to get a lot of natural gas, the fracking, and it does produce CO2. So it's not totally free of pollution because CO2 contributes to climate change. And we have about 70 years. Okay. And so, all of the fossil fuels, everything's going to release some greenhouse gases. In renewables, it's more looking at the production of the materials, right? But by far, coal, oil, and natural gas has the most greenhouse gases. So reliable energy, again, we need reliable energy that emits no greenhouse gases or airborne pollution. So what's the catch, right? So nuclear energy, a lot of people are saying, hey, why not use nuclear energy? There's less, it's not putting out the CO2, it's abundant, it can produce abundant energy, right? And so, it's, so long-term energy that's based on fossil fuels is just not a good plan, right? So renewable energy options have certain limitations, and so we need a non-fossil fuel energy source that has few emissions, that doesn't have as much limitations. So that's why, again, nuclear power is kind of looking at, nuclear is kind of being looked at, right? So there's two different types of nuclear production. There's fission and fusion. Fission is what the sun does. So it takes hydrogen atoms and creates helium atoms out of them, fusing those together. Fusion. Fusion is what the sun does. Fission is separating atoms. So when we separate atoms, we get a lot of energy, or if we put atoms together, we get a lot of energy, okay? the sun is constantly doing this. It'd be great if we could figure out how to do fusion, right? Like an Iron Man and stuff. But right now we just do fission. So fusion is not really an option. It's great, there's no pollution, no radiation, but, and maybe it's an option, but it creates a lot of heat. And if you think about the sun, right? So people are still working on it. But what is, so again, this is what the sun is doing here. What we do is a fission where we break this uranium into other smaller atoms. Okay, so we control the rate of breaking that down, and it's released as heat, and then the heat boils steam, and similar to coal. Okay, and so only radioactive, only materials that are already kind of breaking down on their own can be broken. Don't worry too much about isotope. So uranium is what we use for that. Skip through this. Don't worry too much about these things here. And then this is just diagram, just, it's similar to coal. So one other thing about it is, you have this tiny little piece of material, and you can get as much electricity as 1 ton of coal. So that's why it's desirable, right? But it produces a lot of radiation. Right? So part of it is how we get the material. Again, it has that same mining problems. It has to be refined, and then once it can be used over and over again for a while, but then it now becomes no longer to be able to use. Nuclear reactors can only be used for a certain amount of time, and so you have to then find a way to store this highly reactive waste. So waste and accidents, right? So radiation causes problems, right? And causes all kinds of issues. It's invisible, so that's tough. Don't worry about how we measure it. That's just for your information. So we are already exposed to radiation, and then this would cause more exposure, right? So doesn't seem like that much, except what are we going to do with all this waste, right? So one of the things is, there's not a necessarily safe place to put it. So like when Japan earthquake, the Fukushima problem was a problem, right? The other thing is, where are you going to put it? Because not in my term of office, and not in my backyard, we're going to do this. So we have one site called Yucca Mountain, but it isn't really being used right now. There's been nuclear power accidents. So the one was a partial meltdown at 3 Mile Island. So that wasn't real great. Luckily it didn't cause too many problems. But the Chernobyl disaster caused a lot of problems. So both of these were human error. So that's kind of, maybe we can rule that out somehow. But basically, Chernobyl, the area of Chernobyl, is pretty much not going to be able to be used forever. So all of this area, this was the radiation map, and the areas around. So there's a lot of cancers and things in these areas. Part of why Ukraine is pretty poor, Belarus pretty poor, and some of these areas are no longer being able to be used. So a lot of problems with that. And then the newest one is the Fukushima. So that was an earthquake that caused a partial reactor leak. Okay. So they are being built still, but not as many as there used to be, and a lot of them are being decommissioned. So it's about 11% of the electrical generation worldwide. In certain areas like France, that's 77%. So some countries are a little more. So these are the two in Minnesota. Some countries are a little more pro-nuclear. Okay. These are some power plants and things around that are nuclear. The nice thing is that new plants that are being built are safer, so that's good. The future plant, nearly reactable, nearly impossible. It would kind of have more fail safes to shut things down. So if we can get rid of a lot of the safety concerns, if we can solve that whole waste dilemma, then maybe nuclear could be a good thing. Coal is going down with energy generation, and actually solar and wind is coming up. And as far as costs, solar and wind is now cheaper in electricity generation than coal. So renewable energy, we have hydroelectric, tidal, geothermal, wind, biomass, solar, and hydrogen. So hydroelectrical is taking advantage of potential energy by building up potential energy and releasing that in a systematic way to give you a predictable source of electricity. So United States, 5%. In certain places, you can have lots, depending on what kind of, how much energy production you need and how many dams you can put up, right? So in the US, we have about a 50% potential. We could have about half of our electricity. Compared to Africa, dry country, right? Not very many rivers and things, not a lot of elevation, and so 5% for them. So the advantages: clean and renewable, efficient. Disadvantages: destroys habitat. You've seen this in the Elwha River case, right? Inhibiting fish migration, capturing sediments, population displacement, like in the case of a certain ethnic minority in China. So you can see that it varies, right? So again, it's not for everybody. We don't have a lot of potential. We don't have a lot of elevation in big rivers to do this. A lot of our hydroelectric power is actually coming from Manitoba up here. It's piped in from Manitoba. But on the West Coast, there's a lot of opportunity for hydro. Geothermal. So this is taking advantage of the fact that the Earth is hot in the middle, right? And so you can heat underground water, and then that allows for building up of steam. So you go down, you get this hot water, put water down here, heat it up, and then provide the water. Again, this is not something that can be used everywhere. Where we would maybe see geothermal here in Minnesota is using it as a ground source heat pump. So this is taking advantage of the difference in temperature between under the ground and up in the air. So it's warmer in the summer, warmer in the winter, cooler in the summer underground. So that helps to keep things as you're bringing in the warmer water during the winter. That helps to heat your house, and the cooler water in the summer helping to cool your house. So this, the West has the most potential for geothermal as far as energy production. Wind energy, right? So we've had wind energy for a long period of time. We've used it for water pumping and things like that. So, but electricity generation is pretty new. So no pollution in the production, very efficient. can be developed in rural areas, profitable for the landowner. And there's high startup costs, but then it's pretty much good after that, not a lot of maintenance costs. So electricity generation, so the wind energy would be supplementary, not the solution, because it is intermittent, right? So we need other sources or storage capacity, and that's the new place. We're seeing a lot more battery storage and things. And then the disadvantage is not everybody likes having windmills in their backyard. But when we look again at the west side of the United States, there's some great potential. Obviously, Minnesota, that's why there's all kinds of windmills in this region. And it can be a threat to birds and bats, and so that can be a problem. But a lot of the newer windmills spin at a slower speed, and so that has helped. So we have to be able to use that. Biomass is utilizing things like stored energy in plants and burned. So obviously we used to use biomass a lot. Less developed countries use biomass a lot. And so this can be used, but it's probably not something that we're utilizing as much in developed countries. So this is Dr. Gentry's house, burns wood. Other ways that we maybe do it is we take waste. So where we would maybe use biomass would be, and this happens in Minneapolis, they take garbage and they burn the garbage to produce electricity. And there's controversy with that too. So transportation options, biodiesel, diesel fuel from plant sources, soybeans and vegetable oil. So that's an option. Agriculture, corn for ethanol. This has been a big change and shift in Minnesota. A lot of our corn is now going to ethanol production. For good or bad, it's taking away the food source, so that's the problem. There's other better sources of plants for ethanol out there. Things like agricultural residues, switchgrass, hybrid poplars that could be helpful for that. So I'll just kind of have you read that one. Solar energy, right? So we have three types: passive, active, and solar generated electricity. So passive solar energy would be utilizing, building something to take advantage of the sun. So here you have some way of collecting the warm air or the warm sun to heat up the house in the wintertime. Active solar energy is what you're probably more familiar with. It's the solar, heating water utilizing solar energy. So that reduces heating water and heating the home. And then solar generated electricity is what I really meant for you to say that you probably are more familiar with. So these are the photovoltaic cells. And so the sunlight provides electricity. So it can be placed on homes, power plants, rooftops. You can have something like this where this is a bunch of mirrors that are sending light. This is out in Arizona, that sends light up to this tower that then boils water and creates electricity. The nice thing about solar is it doesn't have to be personal, right? You can have, like at our house, we have solar, but there's also a lot of community solar projects out around us. And there's pretty good potential for the most part across the whole United States, which is pretty good. So no fuel required, quiet and safe, little maintenance, good in rural settings, no pollution, use all forms. You can use it for all forms of energy needs. The disadvantages, some locations are not ideal, a lot of upfront costs. I'll be paying for my solar panels for the next 15 years. And there's, again, that storage problem. So the storage problem comes into someone trying to find these fuel cells to do this. So hydrogen fuel is another one. that could be potential in combustion engines. But again, this is pretty abundant. Hydrogen is pretty abundant, but it's hard to get it into the cell, into the fuel cell, or into the form that it can be used in the fuel cell. And so it's just it's probably not a viable option at this point. Skip on that. So the main thing that you can do right now is decrease your energy demand, right? So if you bike more, if you use less electricity, those kinds of things, that's the best thing. What about electric vehicle? These are getting a lot better. And so that's helpful. Energy policy is another way that you can get involved. We don't make the decision, we make our personal decisions, but the government highly subsidizes and regulates energy production. And so we make the policy by who we vote for. So we're gonna skip that part. All right, well, that's our lecture 4.